All right, good afternoon, everyone. Welcome to Math 1414. My name is Robert DiGiovanni. I think some of you have already seen me before if you watched the orientation video that I put out there. Let me start off by talking about bonus for the class, because this will mean something to you. So every day that I come in here into Zoom, I'm going to look at who has their camera on, who doesn't have their camera on, and I'm going to keep track of it. You're not required to have your camera. However, if you do have it on, I will look at that as being bonus for the class, and it can get you up to 8 points added to your final exam grade. So I think we're going to meet like 30 times or something, 28 times. So each time I'll count, and if you have your camera on every day, then you'll get 8 points on the final exam. If you're there half the time, then you get half the points. If you never have your camera on, you don't get any bonus points. Okay, so start with that, because I like to look at people other than look at a bunch of names. The other thing I want to talk about is whether or not you're in the right class. So I believe you're supposed to have taken an orientation for this class, but I know some people were not able to make it to the orientation. So I know someone already emailed me about this. Who was that again? Are you here?
Yeah, it was me. I had messaged you.
But had you said that you were a nursing major or no?
Oh no, it wasn't.
Yeah, that was someone else said they were nursing and wanted to know. So Gregory, in your case, are you unsure whether or not you're supposed to be in this class? What's your major?
I'm going to business.
Business? Okay, so if you're in business, you may not need this version of algebra. Have you talked to your advisor?
Yes, I'm just I'm conflicted on whether I want to pursue business or switch to engineering. So
okay,
this is
the safe way to go, because it'll cover both bases. Yeah. Okay. Someone's asking about the cameras, and today, yes, I will count for bonus today, starting today. Okay, is there anyone else that's unsure whether or not they're in the correct class? Everyone's sure. So there's two college algebras. There's like the one for people who don't need math, and then there's for the people who do. And this is the one for the people who do. So it's preparing people for different majors, but that's what the orientation was about. So hopefully that answered all your questions. Can we move on then? I don't need to discuss that. If you change your mind, please reach out to me as soon as possible, because if you can really be in the other class is a lot easier than this class. So, you want to probably take the path of least resistance if possible. All right, now the other thing I'm going to need is I need a volunteer who's willing to share their screen so that we can make sure that you know how to get access to the electronic version of the book. Unfortunately, we're supposed to be on campus, right? Like this was supposed to be a face-to-face class. The first 4 class meetings are supposed to be like this, but I don't know. I mean, the way things are going, who knows? Are we ever going to be face-to-face? I have no idea. So in the event that we don't ever get face-to-face, I still need to show you like where you're going to go to access your electronic book and all that. So any volunteers to share their screen?
I can share my screen.
Okay. Is that Josiah? Is that right?
Yes.
Okay, I'm going to make you a co-host, and I'm going to stop sharing mine, and then just go ahead and go to the Canvas page. I'm assuming everybody can get into Canvas, and then we'll see Josiah's screen here in a minute.
I'm going to go to the Math 1414 page for Canvas.
Are you sharing yet or no?
No, I will go ahead and share now.
That's fine. Yeah. Here we go. Okay, so I'm doing this, I'm letting Josiah do this because I can't do this as a student. When I do it, I get in, I don't have any problems, but I want to make sure that students are able to do this. So when you come here, the first thing you're supposed to do to get access to the ebook is go to that link that says set up online ebook homework system. Have you done that or no?
No.
Okay, good. Okay, so then you click on this thing called Red Shelf eBooks. And I think it's supposed to bring up some sort of access code. Just give it a minute. By the way, I'm recording this Zoom session, so you can go back and watch this, although this doesn't even look like it's working.
Yeah, it appears to be fully loaded and I am not seeing anything.
It did the same thing to me earlier. I've been trying for about an hour now.
Really? Okay. Do me a favor, just refresh the page again. Maybe reload it. Nothing, huh? Okay. Go back to the modules part, I guess. Looked like it was still thinking there, huh?
I mean, I can have it loading in a separate tab and we can go back and look.
Yeah, okay. Go back one to the modules, to the click on, okay, yeah, go ahead and access online ebook and homework system. See what happens there.
Yeah, this is just pulling up the blank.
Yeah.
Let's see what's here. On pop-ups. I will get that later.
Okay, try opening it. When you open it, it's probably going to ask you for an access code or something. Oh, maybe not.
Likely.
So if you can read that if you want, or you can blindly accept it. It's up to you. It says that you need to submit a sample of DNA within 24 hours or something like that.
Yeah, seems fine.
Yeah, see, it
Yeah.
shouldn't do this. It should ask you. That other thing is supposed to get that going for you. So I'm gonna have to work on this. That other one didn't load, right? That red shelf thing?
No, the red shelf did not load.
Yeah. Okay, so what's supposed to happen is you click on that first one, brings up red shelf. It's supposed to give you an access code. And then when you click on the other one, you're supposed to be able to put that access code in. And none of that appears to be working. So, well, sorry, they threw this all on me, right here at the end. They threw this on all of us to switch it over. So I'll get that fixed for now. The homework that we have, I'll just have to give it to you. I'll send it to you as just a document, and you can just work the problems, on paper and pencil. All right. Okay. All right. Go ahead and stop sharing, and I'll take over. Thank you for that.
Of course.
All right. Okay, so just to be clear, right now, nobody can access the electronic book. Nobody can access the homework. We'll get that resolved. So just make sure you're checking your Canvas email later today when I send out the homework problems and stuff. That way you'll be able to follow along. So did anyone have any questions about the orientation video, about the way the class is going to be laid out, at least while we're here doing this Zoom stuff? Everyone understand I'm going to record all these lectures. Even if we're face-to-face, I'll record what we do face-to-face. I'll post those later. And then I've started doing the homework solutions. So if you click on the homework solution videos, it'll be me working through your homework problems. So the idea there is that instead of like a solution manual where you just see an answer, you can actually watch me go through the solutions. And the idea here is that you're supposed to learn from that, right? If you're having trouble with something, you're supposed to learn from it. It's not just, don't just watch the homework solutions and be like, oh, I know how to do that. The whole idea is that you try and do the problem, and as you're working the problem, you want to kind of maybe watch the video and make sure we're both kind of doing the same thing. Just watching me do it does not train you to figure out which road to go down. I know which road to go down. The hard part for you is figuring out those paths. So use it the right way. I have not taught 1414 in I think it's been almost 5 years since I've taught 1414. I usually teach calculus 1, calculus 2, calculus 3. I usually just hang out in the calculus sequence teaching that. So this is a first for me in a long time. So I have not done any of the homework problems. I want it to be an experience where I'm experiencing it for the first time in a long time. And so if I make any mistakes, you get to see that, learn from that, because I know, on your end, you're learning it for the first time. So if I make mistakes, you'll be able to see me correct myself, which will be a good thing, I think, for you to see other people make mistakes just like you. Does that make sense? Okay, so what are we doing today? I'm going to call on people. Okay, so I will call on you. I'm going to try and call on everybody every day. This would either be in Zoom or in face-to-face. I would call on people to help me get through problems, all right? And that's how I take attendance. So I'm going to call on you today. I'll just do a random sorting of the roster here, and I'll call, somebody. And if you don't answer, like if you're here but you don't ever answer, then I'll count you as not present. If you answer and you're wrong, I don't care. Okay, I don't care if you're wrong. I just care that you're engaging in the class. That's it. All right. Anything else I want to talk about? Anything you want to talk about? How do y'all feel about this? Math 1414 college algebra. I have not taught a class in a long time like this, where most of my calculus classes, like the students actually like math. Like they really enjoy math. They like the challenge. 1414, you get a mixture of students who are just like, please, let's just get through with the math. I'm done with the math. And then, there's other students who are like, I'm an engineering major. I need this, so we have a big mixture of students here. People are going to be at different levels. So this will be an interesting experience for all of us, I think. Anyone want to share anything? Amanda, did you want to say something?
Yes, sir. It's been about a year since I've done my last math class just because of COVID. I'm
Yeah.
a little nervous. How much review will we start off with?
Well, we're going to review, I believe there's 4 sections of review. So there is a calendar in Canvas that we're going to follow. Here's the calendar. And today we're going to review 4 sections of material. But in reality, I'm actually only going to review R7 and R8. R2 and R4, I think, are basic enough that I don't need to do like a formal review of anything. But if you go to do the homework for R2 and R4 and find yourself like, I have no idea, I think you're going to need to like reach out for help. And that way we can identify any gaps that you have early in the process, as opposed to struggle, fail first exam, and then ask for help. It's always best to identify the problems early. I don't know if that addresses your question.
Yes, sir.
Okay. Any other questions about review or any other topics? So when I call on you, I don't want y'all to freak out, all right? Like, if you don't know, just say, I don't know. I'm not sure. Like, nobody's going to be like leaving the Zoom session going, that guy Gregory, I tell you, he didn't know anything. No one cares. Okay. You're here to learn for you, right? Doesn't really matter what other people think of you, or you know what I'm saying? Like, I'm trying to prepare you for an exam. I'm trying to prepare you for the next math class, which would normally be pre-calculus after this. So let's work together. You have my office hours. You have my cell phone number. It's all in the orientation video and the syllabus. Contact me if you need help. And I think we should just get into it, right? We have a lot to cover in this class. And I'm ready to start with R7. Review section 7, which covers rational expressions. And I like to always start a class by saying, like, what is this class for? Why are we doing this, right? Like, what's the purpose of this? And I'll be quite honest with you. What this whole class is about is like me teaching you how to use a screwdriver, how to use a hammer, how to use a saw, I'm teaching you how to use all these different tools, right? you don't build anything until you get into the calculus sequence. That's when you're doing math that actually relates to the real world, and actually you can do something with it, right? So you have to always keep in mind that this is just skills so that you can build something later. And unfortunately, it makes the subject seem kind of like, why, like why? But it's a lot more than just hold the nail, hit the nail with the hammer. It's a lot more than that. With algebra, there's so many little nuances that you have to get correct in order to be able to effectively use the tool. So, but at the end of the day, we're just learning how to use tools. That's it. Okay. Now, can I proceed? Anything else? Thank you for having your cameras on. I do appreciate that. All right. Here we go. So R7. So I knew before class that we probably wouldn't get into the ebook, but I'm going to show you the ebook just so you see it. This is the electronic version of the book. And this is R7. It's a review of rational expressions. And I could sit here and kind of, go through this page by page. Since it's a review, I thought what would be more constructive is that we go right to the homework. And let's just start doing homework problems. And as we do them, we will see like what things we needed to know to do that problem. Now, when I get to the new material in the class, which will start next time, right? When I get to the new material, solving equations, I'll do it in a more formal manner where I present any definitions, any sort of theorems or properties that we need. I'll present all that, then we'll do problems. Because it's review, we're just going to jump right in, all right? So I guess I'm saying don't expect this to be the way the whole semester goes, where I'm just like throwing problems at you. All right, so here we go. We're going to do this first problem. On the online system, it looks different. When you do your homework here, here's what it would look like. You click on R7. It shows how many questions there are. There's 14. And then it brings up the first problem here like this. So it says reduce the rational expression into lowest terms. That's the first question we're going to try and do. Now, because I don't want to be working with this system and I want to be able to write on my screen easily, I've already brought the problems into a different program so I can have that same problem here and do all my work here on the side. Okay. Actually, I'm just going to copy it. I think I'm just going to copy it and do it. All right, here we go. First problem of the semester. Welcome to college algebra. Reduce the rational expression into lowest terms. So I'm always pay attention to the instructions because they tell you what you need to do, right? So we want to reduce a fraction, right? This is a fraction, we want to reduce it. Reducing a fraction, you can think back to a fraction like this, 15 over 21, right? That's a fraction. If you were asked to reduce that, then what you would be doing is trying to simplify it so that you could make it in its cleanest version. So for a fraction like this, 15 over 21, we would think to ourselves, what number goes into both 15 and 21, right? What common factor do they have? Can someone tell me what both these numbers have in common in terms of a factor?
3.
3, right? 3 goes into both of those, right? So you could just, some people would just do this. They go, oh, 3 goes into that 5 times, 3 goes into that 7 times. And so your answer is 5 over 7, right? I mean, maybe you don't even have to write anything down. You just do that mentally. Everyone's at a different place. But the idea is that we're reducing the fraction, right? I want to show you a slightly different way of doing it that will help us with this. Another way I could have done this is to think, again, that 3 goes into both of those, right? But I could rewrite the 15 as 5 times 3. And I could rewrite the 21 as 7 times 3. And now that I have this broken up into factors, 5 times 3 and 7 times 3, I can see that the 3's reduce, right? They cancel each other out. 3 divided by 3 is 1. So all you're left with is the 5 over 7, which is that answer. So the idea of reducing a fraction really comes down to splitting up the top and bottom into its factors. And that's what we have to do here to do this problem. Unfortunately, first day, first problem, you get your favorite F word, right? Second favorite F word, right? Factor. We have to be able to factor. So starting this class, day one, right out of the blocks, you need to be able to factor. So if you already know factoring has always been your weakness, this is where you're going to have to get proficient with it, and that takes time. So that might mean time in the tutoring lab, that might be time in my office hours. You know, hey, give me more factoring problems. I need to practice. So everyone's at a different place. Let's see how this goes. So I'll start with volunteers since this is day one. Any volunteers? Hold on, I think there's someone trying to get into our class. They keep on texting me. I just want to make sure someone's not locked out. Oh yeah, no, it's not. Okay, so volunteers. Anybody who feels comfortable in factoring the numerator? Go ahead. Is it Carissa?
Yes, it's Carissa.
Yeah, you don't need to raise your hand. I mean, just
Oh.
yeah, just normally in a class, I might want you to raise your hand, but here it's too hard for me to. So just chime in. What do you got?
Okay. So we would take the -27 and try to figure out which numbers multiplied together could also be added together to equal the 6.
Okay, good. You explained that very well. So we are factoring here what is called a trinomial, okay? And when you factor trinomials, one of the techniques is to do what Carissa just said. You look, now you said you look at the -27, right?
Yes.
And you're saying what two numbers multiply to be that, but you said also they need to add up to be the 6 in the middle, right?
Yes.
Okay, that is correct. That is the correct approach. Now, let me ask Carissa, what if there was something other than a 1 in front of the x squared? Like, what if this was 3x squared plus 6x minus 27? Would you do the same thing?
I believe that first you would divide each of the numbers by the number that's in front of the x squared.
Okay, yeah, so there's different roads that we could go. And you know what? This is a very good opportunity for me to explain something important about algebra that I just thought about. When it comes to algebra, we usually are, every problem that almost every problem you ever do in an algebra class, you're starting at point A and you're trying to get to point B, okay? So you're trying to get from the problem to the solution. Now, the path that you take to get to that solution depends on you, all right? It depends on your background, your strengths, your weaknesses. Some people are going to take a path, and it might take them a little longer, but they're going to get there. And someone else might take another path like this. And normally when I take a path, I take like the straightest, shortest path because I've been doing this forever. Okay, so I recognize the shortest path, but it doesn't mean my way is any better than anyone else's. Everyone needs to get to the correct answer. Someone else may do this, wander along, and then finally get there. The thing is, no matter what, to get from A to B, you can't break any rules, okay? You cannot break any of the algebraic properties or rules can't be broken. If you break a rule, then the only way to get from A to B is by accident, okay? It would be like you lost the map, you don't know where you're going, and all of a sudden you stumble upon B. It would be complete luck, all right? So we just want to make sure that when we're doing every problem from here on out, that we're always paying attention to the rules, what's allowed, what's not allowed. So if Carissa does something a certain way, and it's not the way you do it, that's okay, as long as you're both doing something valid that is acceptable and understood to be okay. So Carissa said that if there was a number out here, there would be division through by that number, which could work on some path. Yes, that may be okay, all right? It's not breaking the rules, so to speak. But there is not a number in front, right? There's not a number in front. Well, is there a number? Hold on. Is there a number in front of x squared?
1.
There's a 1. Okay, so it's always implied if it's not there is a 1. Okay, so look, we can sit here and talk about this for another hour, how to do this factoring in different ways and different approaches. I think what I'm going to do is I'm going to share with you the way that I would teach it, okay, because this is a review, but I'm going to share the way I would teach it to my students if it were their first time seeing it. I'm just going to go fast. So what I teach my students is to look at the number in front look at the number in the back, multiply those two numbers together. Okay, so 1 times -27, that gives you this number, -27. And I write it down over here on the side. And then I say, look at the number that's in front of the X, and that's a +6, and I write that down right here like this, 6. Now, people do this different ways, and this is kind of childish, but I draw like this X. You don't have to do this, all right? I say above the 27, I say for multiply, and below the 6, I say add, like this. And so this is what Carissa was saying, basically. Can we mentally come up with two numbers? We have to find two numbers, and I'm going to put them here and here. These two numbers need to multiply to be -27, but add up to be 6. And this part I can't really help you with, all right? Like, you do have to know some level of arithmetic. All right, so -27, two numbers multiply, who's got it?
9 and -3.
9 and -3. Good, so 9 and -3 are the two numbers that when you multiply them, you get -27, and when you add them, you get 6. You good with that? Okay, now the question is, what do you do with that? Right, what do you do now? And again, remember, please keep in mind, I understand that there are different paths, all right? Some of you already know what to do with that. Some of you knew the answer without even doing anything. Some of you can do that mentally, like factoring, that's fine. I'm just trying to show for a person who's really unsure of what to do, what you can do, and it'll work each time, all right? So we've got these two numbers. Now the very important next step. What I'm gonna do, I'm gonna rewrite the original numerator first, like this. What I'm gonna do is I'm going to not touch the first thing, x squared, I'm gonna leave it alone. And I'm not gonna touch the -27 that's at the end. What I'm gonna do is I'm going to take this +6x, and I'm gonna rewrite it using the two numbers I just found, or that someone said it, I didn't see who said it, but I'm gonna break it into two pieces. I'm gonna use the 9 first, so I'm gonna put 9x, +9x because that was a +9, and then the other one's a -3, so I'm putting -3x. And I'm going to put an equal sign out in front of this. So all I want you to look at here is that x squared plus 6x minus 27 is exactly the same as x squared plus 9x minus 3x minus 27, right? These are the same thing. Would you all agree? Like, if I put this and this back together, I would be back up here. So it's not incorrect to write it that way. It's just a different way of writing it. Now, once you get to this step, okay, once you get to this step, what you do is factor by what's called grouping, which means I'm going to put a slash in between the first two terms and second two terms. And then I'm going to look for a common factor out of both of these. So both of these have what in common?
X.
X. So I can pull an X out. And if I pull an X out of just these two terms, I'll be left with an X and then a +9. Let's see. Lorena, are you there?
Yes.
Okay, so Lorena, I'm gonna start calling on people, all right? So Lorena, when you saw this problem, are you at a point personally where you could have factored this a long time ago by yourself, just doing it, or do you need these steps?
I could have factored it already.
Okay, so for someone like that, okay, I'll just say good, okay, like good. You're in a good position. Again, I'm just trying to fill holes in here for people today, just in case, all right? Later on, as we move through this class, I will not take this much time to do a factoring of trinomial. I will just blow right through it. And if you don't know what to do, you're gonna have to go do it on the side, on your own time. But, okay, so, but while I've got you, Lorena, you understand kind of what I'm doing here?
Yes.
Okay, so look at the second two terms, Lorena. What can I factor out of both of those?
-3.
-3. So I pull a -3 out, and then a set of parentheses. Lorena, what would be inside of that parenthesis if you pull a -3 from both of those?
X plus 9.
X plus 9. Okay, good. Now, once you're at this point, because these both have x plus 9 in parentheses like this, what you can do is you can rewrite this as x plus 9 times in parentheses x minus 3. And that is the answer. That's the factorization of the numerator. But I do have a question. Why does this become this? Why does this line become this? Can anyone explain that to me? Because I remember as a student, I didn't quite get it. And I know that there are tons of students that do that step, they get it correct, but they have no idea why it's that. Can anyone explain it?
Because both terms are multiplied by x plus 9, you can factor out x plus 9 from the equation.
That's right. You can factor out x plus 9, which is the exact, I mean, Josiah, you're saying, am I saying that right, Josiah?
Yes.
So Josiah just said it exactly correct. You are factoring x plus 9 out of both of the expressions. The only problem with that, Josiah, is that I think half of the students here aren't quite sure what the hell you mean by that. All right. So what I'm going to do, and no insult to anyone, if there's one of you that doesn't get it, it's good enough. What I'm going to do is on the side, I want everyone to think about this. If I wrote x times m minus 3m, what do both of those have in common?
And
M, right? So most students are comfortable with the idea of pulling an m out of both of those, right? Like they both have an m, so you could pull the m outside and have an x minus 3. Like most of the time students are like, yeah, check, got that, right? The only difference between that and this is that instead of m, it's this whole thing x plus 9 and x plus 9. So the x plus 9 is like the m, and that's the m, and you're pulling an m out. Here's the m out in front, and then you're left with the x minus 3. I hope that that kind of clarifies it a little bit more. You know, if that helps one of you, I've done my job. If not, you just have to remember that when these two match, you put that there and you put the other two things in parentheses and you move on. All right, backing up. All right, so we have just done the numerator. That's it. Okay, now we have to do the denominator. So we need to try and factor this. So I'm going to do that. I'm going to try and squeeze that in right here. We have x squared plus 11x plus 18. I'm going to move much faster through this one. There is a 1 in front. I multiply these two, I get 18. I look at the number in front of x, that's 11. I need to try and figure out two numbers that multiply to be this and add to be this. Those two numbers are
9 and 2.
9 and 2. So then what I do is I rewrite this as x squared plus 9x plus 2x plus 18. So I'm rewriting the 11x as 9x and 2x. I'm going to split it. I'm going to pull an x out of both of those. And on these two terms, I'm going to factor out a 2. And I'll be left with x plus 9. Since these two match, my next line will be x plus 9 times x plus 2. Someone's going to ask me, is it okay to do this? Because that's the way you learned it. You learned it that you take the two things in front, put them in parentheses, and then you put the x plus 9 in parentheses. They're equivalent. Okay, these are exactly the same thing because multiplication is commutative, meaning it doesn't matter what way when you multiply two numbers, the order doesn't matter, right? 5 times 2 is 2 times 5. So because there's multiplication between these, I can do this either way. All right, I think we're ready. Are there any questions? We're ready to finish this problem out. I'm going to go back up to the top. I'm going to rewrite this. I'm going to say this is equal to, okay, the numerator, we did the factorization. It was x plus 9 over x minus 3. And then the denominator was x plus 9 over x plus 2, right? And now I can reduce this, cancel the factor. and I get an answer, let's see, whatever's on top, x minus 3 over x minus 2. And that's my answer. That's it. That is reduced.
Can I ask a quick
Plus-
question? I'm sorry.
Absolutely. Please ask.
Why is it -2 and not positive
Oh,
2?
did I? Yeah, because I'm an idiot. That's why. No, I just forgot. I forgot my plus. Do y'all see that? This was plus, right? I don't know why I put minus. I just forgot to put plus. It's a plus right there. It should be a plus right there. Here I am telling you, like, if you make a little mistake, you're screwed. Well, I just made a little mistake. All right. So that brings up a good point. On your exams, it's going to be very important for me to see your work, because if you make a little mistake like that, I'm not going to count the whole problem off, right? I mean, like, I'm more concerned about the process than I am the final answer. All right. Any questions? So we need to talk about something here that's going to come up later. And when I say later, I actually don't mean to, like, later is in calculus later for some of you. We did something here, right? We canceled this factor. So I want you to consider something for a moment. Are you all familiar with the idea of a function where I write something down and then you plug something in, it spits something out? Like, let me just write it down. Let me see if this makes sense to you. If I write this notation, f of x equals 1. Okay, that is a function where when you plug something into it, what does it spit out? Like, if I ask you to plug 2 into that function, what does it spit out?
1.
1. What if I tell you to plug in -10?
1.
What does it spit out?
1.
1, right? It actually doesn't matter what you plug in. It's always going to spit out 1. All right. Now, I want you to compare that to this function. G of x is the function x over x. Okay, now what I'd like for you to do is plug 2 into that function, into the g function. What would happen if you plug in 2?
Wouldn't it still be
Get
1?
a 1.
You get 1, right? What if you plug in 10? What do you get?
1.
What if you plug in -10?
1.
1. Why are you always getting 1 on the second function? Why are you always getting a 1 here?
Because you're dividing a number by itself.
Yeah, it's a number by itself, and any number by itself, right? That should divide out and be 1, right? So are these two functions exactly the same functions? Could you just, right now, could you just say, hey, look, everyone, that algebraically kind of reduces out, these x's cancel and you get 1. Can I do that? What do you think? I mean, we just did it right here, didn't we? Didn't we just, like, cancel these two factors out and say that our answer is this? Is that legal? Are these two functions exactly the same? What do y'all think?
Yes.
Yeah? Does anyone see a potential problem?
0 divided by 0 would be undefined.
What if I asked you to plug 0 in? Okay, so if I asked you to plug 0 into the f function, your answer would be 1, right? But if I ask you to plug 0 into the second function, you're going to get 0 divided by 0, and that's undefined. Now, if you do any number other than 0, anything other than 0, these two functions are identical. They will always spit out 1. But the g function has a problem when you try and plug in 0. Does that make sense? It's like, one way you can think about functions, I like to think of them as like car washes. You know, you put a car in, it goes through car wash, comes out clean. So the function on the left is like a function that no matter what car you put in, it's going to spit out a clean car, right? But the g function is like a car wash that will take everything but Fords, right? If you put a Ford in, no, can't do it, can't clean it. You know what I'm saying? Like, there's one exception, and that makes them uniquely different. These are not the same functions, even though they almost look identical. So the reason I'm saying this, and I don't know your background with your algebra, but when you cancel these two factors, okay, when you did this right here, there's an asterisk. You know, like when you're signing something, you have to read, and then you have to accept the terms, right? And there's always that little, like read the fine print, right? When you cancel these two factors right here, there's some fine print, right? You are saying if X is not equal to -9, then I can cancel these. In other words, this expression right here, this right here will be equal to this. Those are equal. Those are exactly the same thing as long as X isn't -9. Because what would happen if X is -9 right here? What would happen if you replace X with -9 there and -9 there?
You get undefined.
You get 0 over 0. Do you see that? You get 0 over 0. So anytime in an algebra class, calculus, pre-cal, whatever you go from here, anytime you cancel factors that have variables in them like this, there's small print that we usually don't write. It's understood that there's some sort of restriction now on what X can be. I hope that makes sense. I'll illustrate this more and more as we do more problems, but that gets subtly lost in algebra classes in like high school and stuff. That somehow gets lost. So I want to make sure you understand it here. Okay, ready for the next one? Boy, that was one problem. Took us like 30 minutes. I was taking my time. First problem. I can't find the document now. Oh, it's on the previous page. Okay, so we are going to do the next one. Oh, like I said, I haven't looked at these, so this will be fun. Perform the indicated operation and simplify the result. Leave your answer in factored form. So we want to factor. All right, so what we're looking at, everyone, is what's called a complex fraction. It is a fraction divided by another fraction, which leads me to something that I think we should have a discussion about before we do this problem. I'm going to give everyone something to think about, and then I'm going to do a poll, and we're gonna wait. I should already have a poll. I don't know why it's not there. Okay, there we go. I've got a poll made now. Okay, so I'm going to put a little. We're not doing that problem yet. I'm going to put something up here and see what y'all think. What is 8 divided by 4? Oops. Divided by 2. 8 divided by 4 divided by 2. So I want you to think about what you think that is. Okay. And I'm going to give you 2 choices for an answer. All right. So you want me to give you a little more time? Got you. Do you have what you think it is? So one answer, okay, one answer choice is 1. And the other answer choice is 4. Okay, so I'm going to do a poll here. And I realize some of you may not be able to do the poll because you're on a phone or something, whatever. Just so choice, the first one is choice 1. Okay, and the second one is choice 2. I just want to see what people think of this. I'll give everyone some time to think, maybe 10 seconds. All right, we have almost everybody participating here. So we'll end the poll and I'll share the results with you. You should be able to see the results. A lot of you thought that it was 1, and 2/3 of you thought it was 1, and 1/3 of you thought it was 2, basically. I mean, the second option. Okay, so I have bad news for you. This is a trick question. You can hate me for it, all right? There is no correct answer to this. This is what you call really, really shitty notation, okay? I didn't write the problem correctly. And the reason I'm doing this is because I want you to understand how important it is, these little subtle things in algebra. When you have division bars, multiple division bars, you have to clearly show which one is the bigger of the two. So what I should have done is this. I should have written 8 over 4 over 2, or I should have written 8 over 4 over 2. See, these two notations are very clear as to which operation you do first. On the first one, you do that first. 8 divided by 4, that's 2. Then 2 divided by 2 is 1. So this would give you 1. But if you do it the other way, 8 divided by 4 divided by 2, you do 4 divided by 2 first, right? You do this one first. 4 divided by 2 is 2, and then 8 divided by 2 is 4. So that would give you that answer. So I'm sorry, I tricked you. But the point is that the division bar length is important, all right? That long bar where we put it matters. In this problem, see, remember I told you I haven't gone through this homework, right? It's my first time. When I look at this, I'm a little bit pissed off, to tell you the truth. They have not clearly identified the long division bar. Y'all see that? Y'all see it? It is, I think it's subjective, but maybe we can all agree that they mean that this one's the longer one. It looks slightly longer than the other two. Y'all agree? It looked just slightly longer. I wonder if it looks better in the online homework. Let me see. See what the next problem looks like. It still sucks here. I mean, it's longer, but it's just not very clear. Okay, now with that out of the way, with us agreeing that the long division bar is here, we can proceed. So now the next idea that we need before we can proceed on this. If you ever have a fraction divided by a fraction, you can turn that into multiplication of the reciprocal. What do I mean? If you have A divided by B, long division bar over C divided by D, that is equivalent to taking the top fraction A over B and multiplying by the reciprocal of the denominator. So in other words, you leave the numerator fraction alone and you multiply by the reciprocal of the denominator fraction. This right here is just a property of fractions. That's just how we define division. So what I'm going to do here before I do anything else is I'm going to rewrite this as 8x over x squared minus 16 times, and then I'm going to write 4x plus 16 and then over 6x minus 12. Is that all clear? All I did was rewrote two fractions being divided as a fraction times the reciprocal of the other. Now what I'm going to do is start factoring. So I'm going to look, the way I look at this is I've got like 4 things to look at, and I got to see if I can factor any of these. So let's start with the top. 8x can't be factored. 8 times x is just 8x, right? But what about 4x plus 16? Can you factor something out of both of those terms?
4.
You can
4, yeah. So I'm going to rewrite 8x over, I'll leave the bottom for now. This is a 4 come out and it becomes x plus 4, right? Over, and then what about the x squared minus 16? Who recognizes that? Let me see, let me call on somebody. I haven't called on anyone in a while. Megan, are you there? Megan. I see Megan. Don't hear Megan. So I'm reading somebody's chat. It went to everyone, so I can say it. Gloria, where's Gloria? Gloria. So Gloria wants everyone to know she's horrible at math, but needs it, right? So look, this is an important part of this, all right? Math is always difficult when you don't get it, okay? When there's something missing and you're not seeing that step, math sucks. I mean, it really sucks. When you get it, I think most people argue that it's pretty easy. Like when you understand it, it's pretty simple. So it's just really a matter of like making sure that we are meticulous about all the details. But I'm bringing up Gloria because really, I think there is a part of math that is having a positive attitude. I'm not saying you're being negative, Gloria. I'm just saying that if you go into something defeated, it makes it much harder to be successful. So you want to try and always keep an open mind that you can actually do that, right? Like you can actually do this. I'll share something with you all, because most of the time, like when you're in college and you have a professor, you're like, who's teaching math, you always kind of assume that they were always like good at math. I mean, when I was in elementary school, middle school, I was in private school. So they actually split us up into groups, and they had like the smart kids and then like the normal kids and then like the dumb kids. Back in those days, there was no stigmas, you know, they didn't give a shit about your feelings. Like if you were in C group math, you were in C group math because you sucked. So I was in C group pretty much everything. And, you know, that's just the way it was. I got to high school and whatever, got through it, enjoyed high school, got to college, had fun. And then finally, I finally got my shit together. Okay. And when I got my shit together, I decided to focus and actually try. Like I actually decided I was going to try. And so when I did that, I decided I'm going to pick something that I can prove to myself and to my family, who I pretty much let down. So I'm going to pick something that is hard. That's what I'm going to try and do. The hardest thing I can think of. And well, for me at that, and for most people, it's math, right? Like math is like this enormous, huge monster, right? So that's what I chose. And I amazed myself that when I actually focused and tried and put the effort in, I was able to do it. But I will say your foundation matters. In a class like 1414, you do have to have a foundation in place that is stable enough to stand on. If that foundation's there, you can do this. If the foundation's weak, then that means you'd have to go back and rebuild that foundation. But positive attitude, positive, feel confident in yourself that you can do it. It helps tremendously. All right, I'm going off topic. Wanting to factor x squared minus 16. So Tabby, is it Tabby? Did I say that right, Tabby?
It's Tavi.
Tabby, okay, see, I tried too hard. Tabby, I'm going to, where are you in my roster? Got you, I see. I'm going to change your names in my little list here so I can pronounce it better.
Okay.
Okay, so Tavi. So Tavi had put in the chat difference of squares. Oh, only to me, sorry. On the x squared minus 16. So Tavi is actually recognizing a very important pattern when it comes to factoring that you should have learned when you were factoring. That's the difference of squares. And the formula that Tavi is using is this one. If you have something squared minus something else squared, that always factors to be a plus b times a minus b. So that had to be known. In order to do the x squared minus 16, you have to know this formula. So for us in this, the x is like the a, and the 16 is actually not what b is. 16 is whatever number you square to get 16. So in this case, Tavi, it would be what?
It would be 4.
4. Good. So this is going to be x plus 4, x minus 4. Okay, so again, this is where we talk about foundation. If this right here is causing you a little bit of an issue, it's because you need to have more practice with that formula. You spend a good 30, 45 minutes on that, you'll be fine. All right, but you got to get practice with it. All right, and then the last thing I'm going to try and factor is this bottom right, and they both have a 6 in them. So I'm going to pull out a 6 and be left with x minus 2. All right, we good? For those of you who are like factoring machines and like coming into this class, just like you can factor in your sleep, I apologize if this is something that's really like you're like, oh my gosh, okay. But I promise you there will be a point later in the class where you will be like, please slow down, please wait. Maybe not, but let's just act like it's going to happen. All right, here we go. Now I can start canceling things. As long as I have exactly the same factors, I can cancel them. And I only see one thing that cancels. I see an x plus 4 and x plus 4. Those go away. This is where you have to have the little asterisks, right? The little small print, the little small fine print that says, I'm allowed to cancel this as long as, can anyone tell me what x can't be now?
-4.
-4.
Good. If x, as long as x isn't -4. Now look, this is not something I'm going to test you on, that you recognize that. I'm warning you for calculus, that in calculus, you're going to need to know that now x can't be -4. All right. Does anything else? Go ahead. Yeah, go.
I'm sorry. What would happen if it is -4?
Nothing other than the fact that at the end of the day, what we're trying to do is we're trying to simplify the result, right? So I'm trying to say, hey, look, Amanda, this is a very ugly, big, nasty expression, right? And what we're doing is simplifying it to a new expression. So we're going to get something new here. And what I'm telling you is that if you plug x into this, you'll get the same exact answer as plugging x into this new expression. They're going to be exactly the same result, except if you try -4. If you try -4, you cannot rely on this anymore. You have to go back to this one, and then it would give you 0 over 0 and it'd be undefined. So that's the little catch. Every other number is okay. That makes sense? Good. Okay, so I canceled that. Is there anything else I can cancel or reduce? How about we have an 8, a 4, a 6. Doesn't can't we do like 2 goes into that or something? Or let me write this. How about this? 32x. That's all that's left on top, right? We have 8 times x times 4, so 32x. And on the bottom, I have the 6. I have the x minus 4. I have the x minus 2. So what I'm getting at is this 32 over 6 can be reduced further because 2 goes into both of those, right? 2 goes into both of those numbers. 2 goes into 32 16 times. 2 goes into 6 3 times. This will be our answer. It says in the instructions, leave your answer factored. So when this x minus 4 times x minus 2, I'm not multiplying those back together because it's said in the instructions to leave it factored out. Any questions on that? How is this speed and kind of detail? I'm trying to show enough, but it's our first day. I don't want to like blow y'all out of the water and go too fast where you're like, oh my God, this is going to suck. All right? Good? Okay.
It's
So
all coming back to me.
Okay, good, good. So there's something here that I think is worth discussing. You know, I told you I haven't taught this in so long. I'm starting to realize that all of the lessons I've learned from my calculus students, I'm like wanting to talk about now because they make these mistakes. But there's such subtle things that you have to really make sure you understand them. So like if I were to ask you to do 8 times, what was it up here? 8 times 4 over 6, right? This right here. I'm ignoring everything else that was here, just the 8, the 4, the 6. 2 goes into all of these, doesn't it? 2 goes into each of these?
Yes.
So can we do like 2 goes into 8 4 times, 2 goes into 4 twice, and 2 goes into 6 3 times? Is that right?
No.
Why is that not right? Josiah is correct. That's not correct. That is not right. But see, it's a little harder to explain why, right?
Is it
Why
because
isn't
of
that right?
PEMDAS? Like you do the multiplication first and
You could convince yourself it's not true because of PEMDAS. You could convince yourself that that doesn't work because PEMDAS, you're supposed to do this multiplication first. But let me put something next to this. What if it was 8 plus 4 over 6? Then can you do 2 goes into here 4 times, 2 goes into here twice, 2 goes into here 3 times? Is that legal? Yes, that's okay. So do y'all see how this is this can be very confusing, like why it's okay in one sense, but it's not okay with the other one? So I'm going to try and help explain why. All right, I'm going to try and illustrate this and let's see what happens. On the first one, if you look at that 8 as 2 times 2 times 2, and you look at the 4 as 2 times 2, and on the bottom you look at the 6 as 3 times 2. So what I've done is I've broken up the 8, the 4, and the 6 into what we call its prime factorization. When you're at this point right here, you can only cancel one of the 2's, right? Only one of the 2's goes away. And so when you cancel those 2's, you still have all of these 2's here, and you have that 3 down here. So 2 times 2 times 2 times 2, that gives you 16 on top, and on the bottom you have 3. That's the correct answer. Does everyone see how this becomes this? Any questions on that? But do you see that if you did it this way, if you tried to do it this way, do you see the top would be 8 and the bottom would be 3? And that's not the same answer. And in math, we can't have something and get 2 different answers, right? You can't be like, oh, one way you do it, it's this answer. The other way is this. We have to all get the same answer each time. So it can't be that, which means this cancellation isn't legal. So why is it legal here then? Because I said it was legal, right? So why is it legal? Let's see what this comes out to be. Watch me try and convince you of this. 8 plus 4 over 6. All right. And try and convince you why you're allowed to cancel a 2 from each one. If I pull a 2 out of the top and I pull a 2 out of the bottom, in other words, I rewrite 6 as 2 times 3, then I can cancel the 2. And what you're left with is 4 plus 2 over 3, which is exactly what you get here when you reduce everything by 2. So look, I don't want us to get sidetracked with this. Well, all I'm trying to point out to you is that these are the nuances I'm talking about in algebra, is when you do something and then you're like, not sure if you can do it, but you do it or you're real confident you can, but you actually can't. Once you start to get a grasp on those things and feel confident about what you're doing, it becomes a lot easier to do. If it's still questions and gray to you, then it can be very challenging. So if during this semester you're having issues with little things like this, just get with me and we will drill it down until you get it, all right? Until you understand it. All right, let's move to the next one. Wish we had more time. I'd just let y'all work on some on your own. Okay, the next one I'm not going to do, number 3, because it's similar. It's similar enough. Excuse me. My door is. Gosh. Sorry about that. It's my wife's dogs. All right, so number 3 and number 4, I think those are similar enough to what we just did that there's no new idea there. You know, a fraction over a fraction, you flip, you factor, cancel things out. I think those next 2 are okay. How about this one? Ooh, oh my goodness. These look like torture. Let's do number 6. That looks pretty bad. Okay, I'm sorry, I swallowed wrong. almost died here. All right. This is very ugly. I'll come back on camera whenever I've cleared my mind. Okay, so this is very ugly, but I'm going to rewrite it. Complex fraction. I'm laughing and choking at the same time because this is so ridiculous. Okay, so there's my numerator. I'm going to flip my denominator over and multiply. I keep saying those dogs are going to kill me one day, and it's right. Something's going to happen. All right, here we go. Okay, that's just the thing we did before, right? We're saying, okay, that's the longer bar, whatever, and then just flipping it. Now, factoring. That's a lot of factoring to do. We have 4 different things to factor. So here's what I like to do, because I mean, we won't be able to do this all the time, but let's do some group activities. All right, this will be fun. Well, I don't know about that, but I'm going to put you all in groups. And let's see here. We'll see how this goes. I'm going to put you all in 4 groups. Do not go into these rooms yet. Let me just ask you, when you get invited right now, does it tell you what room you're getting invited into or no?
Yes.
It does? Okay. So I want group 1 to do that factoring. I want group 2, so this is group 1. You'll do that one. Group 2 will do this one. Group 3 will do this one. Group 4 will do this one. All right. So once you've copied down the problem, or just the part that you're going to do, I want you to go into the group, go into the room. And if you want to work by yourself, that's fine. But what I want is that everyone in the group at least talk about what the answer should be, how they got it. And that way the group as a unified voice can come back to me and be confident that, yes, this is what 1 factors to be. And then we'll put those answers together and we'll see what happens. Okay. And let's take, it's 2:07. I don't want to take more than like 7 minutes. Okay. Let's go ahead and hop in, and I will bring everyone back in about 7 or 8 minutes. Enjoy.
Hello?
Hey, sorry, Adam, I had to step away. What's up?
Oh, sorry, I had to leave the Zoom chat for a second. I was wondering if you could put me back to the breakout.
Do you know, were you in a room yet or no?
I just had to leave for a second to make a
Do you
quick
know
phone
which
call.
room it was?
It was room 1.
It was one, okay. Yeah, there you go.
Nice. Thank you.
Uh-huh. It's another 10, 15 seconds, everyone will be back in here. Okay, I hope at least you got to like talk to each other. Group 1, representative from group 1 want to talk about what they got or tell me if they ran into any problems?
Well, the answer we got is x minus 2 times 5x plus 2.
X minus 2 times 5x what?
Plus 2.
Plus 2. Okay. Were there any issues on that need to be discussed?
Not really.
Okay, how about group 2? What did y'all get?
We got x plus 5 times x plus 6.
You didn't have a 5 anywhere? No?
I think we had missed a step.
Okay.
Is it supposed to be 5x plus 6, x plus 1?
Okay, yeah, so let's do this. Let's go through it. I'm gonna go fast, all right? Let's go through this one. You have a 5 here and a 6 here. So I multiply those two together, I get a 30. Then I look at the number in front, 11. With me? Two numbers that multiply to be 30 and add to be 11.
6 and 5.
6 and 5.
Mhm.
Okay, now the important step, you take the original problem. You rewrite the 5x squared in front, the 6 in the back. You rewrite the 11 using those two numbers.
That's the step we forgot. We had everything up to that point and then didn't do
Okay.
that final step.
Now split it. Pull out a common factor from here. They both have an x. And then this is very important. Can anything be pulled out of both of these? They don't really have anything in common, do they? But you have to pull something out for this method to work. So we pull out a 1, which doesn't change anything. And you put in the parentheses 5x plus 6. Now that these two match, you write down 5x plus 6. And then in the other parentheses, the two things in front, x plus 1. So this top right should be 5x plus 6 times x plus 1. Any questions? How about group 3? Did y'all get the bottom left, or did y'all run into the same issue there?
No, we got 5x plus 6, x minus 4.
And let me check it. 5x minus 20 plus, yeah, that works. Okay, good. And then how about group 4? Did y'all get the bottom right?
No, we were kind of stuck with the number in the front.
Okay, yeah, so do you see now how this would have worked? Let's try and do it. You multiply those two together, right? 25 times 4, you get 100. The number in the middle is 20. Two numbers that multiply to be 100 and add up to be 20. What?
10 and 10.
10 and 10. So now you rewrite the bottom, the fraction, or sorry, the original trinomial. You rewrite it, you write 25x squared plus 10x plus 10x plus 4. So you split that 20 into two 10s. Split it. What can we pull out of the first two?
The 5x and then
You'll be
5
left
plus 2,
5x plus 2. And then out of the second one, what can you pull out of here?
a 2.
A 2. And then you're left with 5x plus 2.
So just 5x plus 2 squared.
Yeah, which will be 5x plus 2. That's what they have in common. And then in the other parentheses, another 5x plus 2. Which you could write this as 5x plus 2 squared, but I'm just going to leave it like this. And then at this point, we try and cancel anything that we have common factors. So 5x plus 6, 5x plus 6, one of these 5x plus 2s, and then everything else is still there. Nothing else goes away. So on top, I have this and this, and on the bottom, I have this and this. So our final result will be the x minus 2 times x plus 1 over the x minus 4 times 5x plus 2. And remember, there's a little asterisk here about, we did a bunch of canceling, but we won't get into that. There we go. Okay, I hope that helped kind of refresh your mind on how to go through the factoring. Let's move on because we have more to do here. The next problem that I want us to look at is this one. So perform the indicated operation, simplify the result, leave it in factored form. So for the first time, we have subtraction between two fractions.
I have a question.
Yeah, go ahead.
I'm sorry, with the last question, is there a reason why for the denominator you switch the 25x squared and the 5x squared when you do the multiplication equation?
Where?
Okay, so if you go to the normal, the question, like the actual question, how it says 25x squared, and then when you write it out, you put the 25x squared on the bottom. Is there a reason why? Because I think that's what I was getting confused about as well.
Why this is here and this one's
And
on
now
top?
on top, yeah.
Okay, yeah, I'm using that property of fractions right there, where you have
Okay,
a fraction over a fraction. You leave the
Okay.
first fraction here and you flip the second one over.
okay, thank you.
Another way we can say that is that division is the same as multiplication of the reciprocal. I don't know if you remember hearing that before.
Yes,
Division is the same as, so dividing these two things is the same as multiplying the reciprocal of the denominator.
okay, thank you.
Okay, on this one, we're asked to subtract two fractions. So I'll remind you, if I asked you to take 8/5 and subtract, let's say 4/5, the way you subtract fractions is the first thing you do is see if they have the same denominator. If they do, like they do in this case, you leave the denominator alone and then you just do the subtraction on top, 8 minus 4. And so this would give you 4/5. That's how we do subtraction of fractions. So on this, when we're subtracting these two fractions, we want to see, do they have the same denominator? Which in this case, they do, right? And so all I have to do to figure out, to simplify this, is to rewrite this, write the denominator they have in common, and then take the numerators and subtract them. So be careful here. You have to do 4x plus 5 and subtract from that the other numerator, which means you're going to have to put that 3x minus 8 in parentheses. That's where students make the biggest mistake here. When they're subtracting this numerator, they do not distribute that negative through to both. The negative must distribute to these. That's why I have it in parentheses. So it'll become 4x plus 5 minus 3x plus 8 all over the common denominator. And then in the numerator, I collect like terms. So like these two go together, right? 4x take away 3x. And then 5, I'm going to add 8 to it. And that should give me, let's see, just an x. And then 5 plus 8 is 13. And then over my common denominator, 5x plus 6. And that's it. Any questions there?
Is
it-
there a reason why it became +6 instead of -6?
Yeah,
For the answer.
because I don't know. I'm just,
Hmm.
I'm gonna need you all to be that, like, pay attention to that. I'm just, yeah. I think what's happening to me is as I'm getting older and doing less algebra, I'm not being as meticulous about things. That's no excuse. I'll tighten it up, don't worry. Okay, keep going. Next problem. Same thing. They want us to subtract two fractions. Well, we have an issue this time. The denominators are not the same, right? This and this are not the same. So you can't just subtract them. You have to do something. So I'll remind you, let's say we had 7/5 and we want to subtract, let's say 1/3, right? You can't do subtraction because you have different denominators. So what do you have to do?
Find the common denominator.
The common denominator. So you'd look at the 5 and the 3, and you try and find a common multiple, least common multiple, which would be 15. And that means you have to turn both the numerator and denominator, or sorry, you have to turn the denominators into 15s. So you'd come in here and you'd multiply this first fraction times 3/3. you multiply this fraction times 5/5. And once you do this multiplication here, you get 21/15. Then minus, you do the multiplication here, straight across, you get 5/15. And now you can put them together because they have the same denominators. So this becomes 21, take away 5/15, which is going to be, I can't do arithmetic, 16/15. Is everyone clear on the idea of when you subtract two fractions, different denominators, you got to get a common denominator and then you can put them together? So we have to do that for this problem, right? Unfortunately, we're working with variable expressions and we're not working with numbers, right? So it's a little more complicated. So what we do is we look at the two denominators and we think about what would happen if we multiply these two together. That would give us our common denominator. So what we need to do is multiply this first fraction by whatever's missing. So I need to multiply by x plus 6 on the bottom and x plus 6 on the top. I'm going to put those in parentheses. And then on the other fraction, I need to figure out what's missing. Well, that's the other denominator, which is x minus 4 and x minus 4. So I need to multiply those. And just like we did over here, now I'm going to multiply these two together, get an answer. These two together, get an answer. When I do that, they should both have the same denominator, and then I can just subtract across the top. So here we go. If I multiply 8 times this, I'm going to write it this way, 8 times x plus 6. And then the denominator will be the x plus 6 times the x minus 4, which I'm not going to multiply. So that's me multiplying those two together. And then I'm going to say minus, now I'm going to multiply those two together. So I'm going to put the 6 times the x minus 4 on top. And on the bottom will be the common denominator again, which will be x plus 6 times x minus 4. Any questions up to that point? We're good? Same denominator. Now we can just rewrite this as that common denominator on the bottom. And then on the top, I'm going to do something. I'm going to distribute the 8 through. So 8x plus 48. And then very careful here. Remember that minus sign. It's very tricky. That minus sign I'm put here, but then I'm put a parenthesis. And I'm going to go ahead and multiply the 6 through to see what two pieces I'd have here, which would be 6x minus 24. But I still have this minus here, so I have to distribute that minus through. The minus being distributed through changes the signs. We're almost there. And now finally collect like terms. So I have these two can go together, those two can go together. We should have 2x on top, 72, I believe. There we go. Any questions on that one? For sure.
So in order to get the same denominator, we have to multiply by the other denominator? Is that what you're saying?
Pretty much, yes. In this case over here with numbers, it's a little different. But whenever you have variable expressions, you're basically, your common denominator is going to be both of those factors together. So whatever's missing on this one, in other words, the other denominator has to go on top and bottom. And on this one, the other one's denominator has to go on top and bottom.
And we don't have to add them together. We can just have them separate the entire time.
On the bottom, you mean?
Yes.
But yeah, leaving it like this and not multiplying it out, you mean?
Yeah. Yes.
Yeah, only because it says leave your answer in factored form. If they wanted, well, it wouldn't be wrong. wrong to multiply this out. You could, it's not incorrect. They're just saying, go ahead and leave it like that though. Okay, let's look at the next problem. Oof. Looking at the time here. Let's see if we can get the 10th one here. They're starting to get messy. Okay, we want to subtract these two. Do they have the same denominator? No, right? So before you go trying to multiply both top and bottom by what the other one's missing, like Gregory was just talking about, what I'm going to do first is factor them. All right, so x plus 9 over, and this is going to be x minus 7 times x plus 4. So I'm not showing this step, but I'm trusting that all of you, given enough time on the side, could factor that out to be this. And then on the other one, same thing, 2x plus 1 on top. And then I'm going to factor out the bottom of this one. I'm going to do that hopefully mentally. What is that? 9 and 7. So x plus 9, x minus 7. So again, I'm not showing the factorization of the blue or the green. I'm just telling you that's what they turn into. Now, when I look at this to put these together, so Gregory asked a good question. So is it just like, you know, whatever the other denominator is, that's what you put top bottom? This is a good example of, you don't want to necessarily take that perspective. You just want to look at, like, look at this denominator right here and see what is this one, what does this one not have that this one does? So they both have an x minus 7, right? This one has an x plus 4. This one has an x plus 9. This one's missing the x plus 9. So I could multiply the top and bottom by x plus 9. Gregory, does that make sense?
Yeah, yes.
And then what would this one, what would I need on this one though to make a match?
X plus 4.
The x plus 4. So if you look at this now, they both have the same denominator. X plus 9, x minus 7, x plus 4. X plus 9, x minus 7, x plus 4. But you still have to do the multiplications across the top, which means you have to multiply those two together, and you have to multiply these two together. So I'm just going to write the next line. I'm not going to actually do it yet. It's x plus 9 times x plus 9 over the common denominator. Minus, I still have to multiply 2x plus 1 times x plus 4 over the common denominator. And so what's left for me to do is to actually multiply those two together and those two together. Because I need to actually subtract these. I haven't subtracted them, but they do have the same denominator now, right? Like this denominator and that denominator match. The most common mistake that I see with students at this step of a problem like this is that they do this. Now, I agree that that's legal. What you just did is legal, but the problem is you just undid what you did in the previous step, right? Like you started out with this thing, and then we introduced the x plus 9 over x plus 9, x plus 4 over x plus 4, so that we could get a common denominator and put them together. And then you went and undid it, which means that you're right back where you started. So don't cancel those. Instead, we're actually going to multiply these together. So I'm going to FOIL here to here, here to here, here to here, here to here, and then do the same thing here. FOIL like that. Now, I'm going to assume you know how to FOIL. I hope that that's okay. I'm just going to tell you what this becomes. This becomes x squared plus 18x plus 81. That's what this numerator is. And then when you FOIL this, you're going to get a minus sign. I'm going to put in parentheses because I still need to distribute that minus through. But this will give you 2x squared. Let's see, what's that? 9x plus 4. And then all of this is now over your common denominator. We have two more steps. Distribute the negative through, and then combine like terms. Any questions while I'm doing this?
Why is the expanded or the completely added together form, but the first equation plus 18x? Because I thought we were only multiplying the x times the 9.
You're talking about right here? Why is
Yes.
that? Because when I'm doing x plus 9 times x plus 9, I do x times x first, which gives me x squared. And then I do that times that gives me a 9x. And then I do this times this. which
Oh,
gives me
okay.
another
I see
9.
it.
You
Thank
good? Okay, good question. And then the last one would be your plus 81. And then I went ahead and combined those together. 9 plus 9 is 18. X, sorry, 18x. So that's all over the common denominator, which is x plus 9 times x minus 7 times x plus 4. Oh, yeah, okay, almost there. Put like terms together. Here's an x squared. Here's a minus 2x squared. Those together give me minus x squared. Then I have an 18x and a take away 9x. That just should leave me with a 9x. And then finally 81 take away 4. What's that? 77. All of that over the common denominator. Okay, it's starting to get messy pretty quick here, huh? All right, so we are out of time. The homework assignment for this section, there's still quite a few problems to go through here. Well, there's about 3 or 4 more that we didn't do. So what I'm going to do is I'm going to see if I can't send you homework problems. Well, I'm going to send you homework problems. Hopefully they'll be different than these. But I think that what you need to try and do is see if you can do like the first 10 problems. So when I email it to you, I'll remind you, just do the first 10. If you can do the others, go ahead, but just for now, the first 10. And in terms of our schedule today, we didn't do R2 and R4 because I thought those were a little bit too basic for us to spend time on. Rational expressions are super important, so that's why we spent all day on it. R8 we didn't touch, so we will start class next time with R8 and then move into 1-4. I'm going to work on why y'all can't get into the ebook. I'll work on all that, and just stay tuned on your email for information, okay? All right.
Wait,
You're free to go, but I'll answer questions if you have them.
okay. So yeah, we were supposed to access the red shelf ebooks, right?
Mhm. It
And
wasn't working though, right?
well, I just got the code from it.
So when you clicked on it, it gave you the code?
Yeah, so whenever I let it load it to my shelf, it opened it and I clicked on it and I just scrolled down.
Can you share your screen?
Oh, I did it on my phone. Let me do it on the
Oh,
screen.
you did on your phone? Okay.
Yeah.
Has anyone else been able to get into it where they can see their code or no? No?
Able to get,
I'm sorry?
I was able to get into it.
You were?
Yeah.
What browser were you using? Are you using Chrome?
Yeah. I had trouble at first, but I don't know, something just happened and I was able to get it.
What the heck, man? This is driving me crazy. I've had so many problems with this stuff.
It just worked for me now.
It did?
Like just now, yeah.
Can you share your screen
Sure.
if you don't mind?
No, not at all.
Oh, you still are a co-host. You can still share. Let me
Yeah, I
stop.
can
sharing mine.
still share.
You can stop sharing mine. Hold on. Okay, so you clicked on it and now it loaded, right?
Yes.
And you got this right here. Click on it. And then there's a code. So yeah, you can copy it, clipboard or whatever. All right. And
I
so
need to go to
let me
it.
see. Register. Hold on. No, try it with that first link. Just see what happens.
This link right here.
Just see. Whoa. Go back to the Canvas page for the class because you have the code on your clipboard, right? Try and access try and do that. See what happens. Go ahead and open it. Go ahead and accept that. Okay, so do you have an account or no?
I do not.
You do not. Okay, so you would have to set one up, okay? Yeah, go ahead and just go through that. Let me see what happens here. Okay, we don't want to do this on camera, but you create the account. At some point, it's going to ask you for the access code, and it should, you know what? Yeah, why don't you stop sharing? Stop
Here,
sharing.
let me fill this out real fast.
Yeah, fill that out, get through that screen, and then you can share again. I apologize for keeping you all around, but I still don't understand why it's working and then not working. Maybe they fixed it in the time that we've been in class.
Do we need a course ID because it's asking for one?
I was just gonna ask.
Does it ask you for a course ID?
Yeah, it's asking me too.
Yes, that's the first step, and then our email, and then we enter the code and we'll have it.
Yeah, but see, it shouldn't do all that. Okay, I'll give you the course ID anyway. Let me get it on my end. I'll do that while he's doing that. Let me see here.
While creating the account, do we use our personal emails or school email?
It doesn't matter. I would just use the school one, but it won't really matter. My courses, where is it? Let's see here. So I have 2 students enrolled already. How did 2 students get enrolled? What?
If I took this class last semester, would I already be enrolled in it?
You wouldn't be enrolled in this course, but you would have an account. You would have an account, so you could just log in under your old credentials.
Okay.
Okay, so I'm gonna, in the chat, I'm going to send everybody the course ID. I hope I'm not screwing up by doing this, but this should do it. Let's see. It's my last name, DiGiovanni 25343.
I've gotten through the creation process.
Okay, everyone see the screen? You put in all his information and now access code. You should just be able to right click paste or
Don't think, oh, it is gonna work, yeah.
Finish. And did you already put in the course ID?
It didn't ask me for the course ID.
It didn't. See, that's weird because it's asking some of you for it and others not. See,
When I did it, it didn't ask me for it.
yeah,
When
see,
I-
I think when you go
I
in-
entered the course ID and then it said that we can't access it. We have to do it from the Canvas.
yeah, okay, good. So go back and do it the way that he did it. Did you see the way he did it? With the red shelf? No? All right. Do you want to do it right now? You can share your screen. We can walk through it with you. It's up to you.
Okay, I'll share my screen.
Do you have time for that?
Yes, I do.
I have probably another 10 minutes and then I got other commitments. So let me see. Make co-host. All right. It's Tavi, right?
Yeah.
Okay, so Tavi's going to share screen and walk through this again and see if everyone kind of follow this.
Okay.
Here we go.
Can you see it?
Yep.
Okay.
Okay, so you already got your code, right? You copied that?
Yes, I copied the code. Well, I have to do it again because I copied the course ID.
Yeah.
Okay.
Okay, so now don't do anything else. Go back to the main homepage of this class. So just click on home from here.
Okay.
Then go to access online ebook and homework system. There we go. Yeah, I'm gonna remind you later. Open My Lab Mastering. So the yellow-ish thing, yeah.
Mhm.
Agree to this. Everyone following this? Okay, you don't have an account, right?
I do have one.
You do? Do you remember?
Yeah.
Login to that?
I don't remember it.
Okay, well,
I'll just create another one.
are you sure?
Mhm.
Okay, it's up to you. But, okay, so look, at this point, I think we can stop here because at this point, you're gonna create the account, it's gonna ask you for the access code. And when you put it in, it should know what class you're in. Because of the way that you went in, you clicked it from the Canvas page to get in, it should know. Does that make sense?
Yeah.
Okay. See how it goes, everyone. If you have any issues, let me know. Does anyone have any more questions on that? I'm happy to let someone else share their screen. It doesn't matter.
I do have a quick question about the homework.
Mhm.
What kind of format would you like it in? Would you like us to show you our work and maybe scan it in, or?
So you're asking a great question because I don't remember how I have your grade broken down. So let me go look at the syllabus because I don't remember what percentage, if there even is a percentage on homework. Okay, so if you do it on the online system, it's just going to be graded there and that's it. I'm not going to necessarily collect it for anything. If we're face to face, then there will be some time, like when we do actually go face to face, if we do, then we will do something where I ask you, hey, bring your homework next time, and you'll just bring your binder or wherever you're keeping your homework, and I'll just kind of look through it to make sure you did it. That's about it. Yeah. Am I answering your question?
Yes, definitely. How about for the first one, since we're not online yet, or if we can't get online?
Yeah,
Just
just have it, written down, and, remember, it's not, I'm not so concerned about, you doing perfect on the homework. I just want you to learn and ask questions. If you get to something and you can't figure it out, to be able to ask me for help, right?
Okay, awesome.
So I look at the homework grade as almost like a free 15%. Because if we do it online, you're gonna have to put answers in, but I just really don't even care if you're getting everything right. I just want you working. I want you doing math, like writing math down. That's the main thing. All right. Okay, well, I'm gonna head out, and if something else comes up between now and Wednesday, just text me or email me.
Thank you.
Okay, take care. Y'all have a good one.
Thank you.